Ht12D. So pin number, so I got the pin names. So the short descriptions of those pins, or those 18 pins of Ht12D decoder, is just like this. Pin, called the pin A0 to A7. A020, A020, A7. This one, we call them address OT, address OT, address pin. Say address pin. Say address pins. So another responsibility, another function of the decoder is actual to remove the address from the coded information. It's just like when you receive the letter, you just read that the letter, the address, if it's yours. Once you finish it, you destroy the envelope to take and read the letter within that OT. Right? So the letter is just like OT, the binary information. And then the address on top of the envelope is actual, and the address on the top of the letter is just to provide the unique identification in the network. Then we have VSS or VDD and the VSS pins. So VDD and VSS pins, these we call them power and the ground pins. Say power and ground pins. So power, this is voltage across source. VDD is what? Short abbreviation of what? Voltage across what? Drain. So it means that the major components, electronics components for this Ht12D decoder are field effective transistor. We didn't say MOSFET, we just call them field effective transistor because we have two types or we have three types of field effect transistor. The first one is called what? Junction field effect transistor. The second one is called what? Metal oxide semiconductor field effective transistor, or called what? MOSFET. So this we call them power pins. Again, I get to this back. So now, Benjamin Joseph went to take Gertrude in. Okay, then we have again some other related pins. AD8 to AD11. So AD8, AD9, AD10, AD11. These we call them output pins. So these are the four output pins of 40 of Ht12D decoder. Are we together? A. Then the other pins is called what? In. So in this we call the input pin. Input pin of 40 of Ht12D what? Decoder. Then we have oscillator 1 pin. I think that the space is not enough. So you have oscillator 1 pin. So you have again oscillator 1 and the oscillator 2. So this we call them Johan. This we call them oscillator what? Oscillator pin. Seni, what is undiscussed? The pins that we did not discuss. Seni is not in the class. Kevin, which pin we didn't discuss? Also, Kevin is not in the class. Lucy, which pin we did not discuss? Which pin we didn't discuss? Also, Lucy is not inside the class. Brighton, which pin did we not discuss? Pardon? Insulator pin? Oscillator pins, according to Brighton oscillator pins. Daniel Fortunatus, which pin did not discuss among the 18 pins? You see, you can analyze. So also, Roberti, Fimbo. Pin number 17. So we didn't discuss only pin number 17. We have discussed all the other. We have provided description about all the other pins except pin number 17. Get it? Nura. So pin number 17 is called the VT. VT is abbreviations of valid transmission. Valid transmission pin. Say valid transmission pin. Class say valid transmission pin. Alquino say valid transmission pin. Again, what is valid transmission pin, Alquino? It's a pin which is connected to the receiver. Okay, so now we have a clear understanding of the general concepts about Ht12D decoder. Right now, the next question that might come in your mind: how can you use Ht12D decoder on building electronics circuit. Can I have it? On building electronic circuit. How can we use it? The question you have understood. You know that what does it do, and also you know its physical appearance. You know the pins names, the pin functionality, and whatever. How can you use it to build electronic circuit or to build a digital receiver circuit? That's the next question. How can you use Ht12D decoder? How can you use Ht12D decoder? Decoder constructing there or constructing. How can you use the Ht12 decoder in electronics communication system? So how can you use Ht12D decoder in electronics communication system? So he said that in order to use the Ht12D decoder, for the online students, you can pause the video and try to think how you can use it by following the following steps of connecting it. The following steps. So the first step, so simply there are some steps, there's a common steps, or there are some similar steps to how we use the Ht12D encoder to design or to construct a wireless transmitter, and the same steps might be used in case of using Ht12D decoder in the receiver part. So the first step, say first step. So it's better to teach you these steps and then we draw the overall schematic circuit diagrams, and that will be all about the decoders. So the first step, we say that connecting the power supply unit. Okay, now. Okay, connect the power supply. To the 18th pin, or we call it VD. So you have to connect these pins first of all to the power supply, but we are not allowed to turn on the power supply, right? Yeah. So to connect it, it's not just you have turned it on, no. That's the first step. The second step, just go back to the 9 steps of using Ht12E encoder. Just open that. That was workshop 6 or workshop 7. Open workshop 7. Then just we had asked the same question in case of Ht12E encoder. The first steps, we connected what? VDD to the power, or VSS. VSS, fine. So the first step we called VSS, so for this case the second step. So say that, then we say that connecting the 9th or VSS pin to the what? To the common what? Common ground of your, let's say, your receiver. So this is the first step and second step that always you have to think whenever you're dealing with integrated circuits. You have to connect, you have to supply power first. Right? According to workshop 67, they say the step is what? Connect what? Connect what? 5 address pin to the what? To the power supply. So you say connect 5, connect the first 5 address pins. Which means a what? A0 to what? A4 pins. Connect them to what? To the power supply. Say power supply. Say power supply. Remember that, hello, stop writing. Remember that we said, or I told you, Ht12D decoder working in pair with Ht12E encoder. So even its connection, 80% of how you connect them or how you connect the external peripherals might be the same. Yes, there are a few differences that you will see. If we, in case in the Ht12E encoder, we connected maybe 4 address pins to the power supply. Similarly, in Ht12D decoder, we have to connect 4 or 54 address pins to the power supply. So what you have done on the part of the encoder, we have to do it in the part of 40 decoder. Why? Because encoder and the decoder work as a pair. So it's just like a pair of your shoes, or a pair of your shoe, right? So a pair of your shoes, what happened? You find that a pair of your shoe. So a pair of your shoe, the way it is, it has some similarities and some little differences. Similarly for Ht12E encoder and Ht12D decoder. Right? So bear this one. If you wanted to check, you may try. You may connect the first 5 address pins of the Ht12E encoder to the power supply, and then say that, okay, let me connect the first 2 address pins, the power supply, and see what happened. Because for me, I tried it. Okay? As electronics and telecommunications serious engineering students, we just give you guidance of how to reach the destination, but you are also allowed to try what you've been thinking about to see whether it's work or whether it doesn't work. You may come up with something that suggests that even if you do this connection, it's going to work. Are we together? So it should not be limited with what we are actually teaching you to do. Number 4. Then we say what? Connect what? 3, I know that you always understand when you've been taught with respect of something else. Connected the 3 remaining what? Address pins. What are their address names? A5 to what? I'm talking to the entire class. A5 to what? Pins. Connect them to the what? To the common ground. So out to the first step, you are done with the left hand side or with the left hand side of Ht12D decoder. You have already used all the 9 pins on the left hand side of Ht12D decoder. Right? 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 Then the 5th step for Ht12E encoder. Read the 5th step, Johanna Samandito. So that day you are slumbering, you are not writing. You said I will write. And what happened? Step number 5, what did he say? Connect what? Connect 1. Either 1 or 2 or 3 or forward. So in case of the decoder, this is how we rephrase that sentence. Connecting the data pin of the 433 megahertz or 315 megahertz RF receiver module. So connected the data pin of the 433 megahertz or 315 megahertz RF receiver module to the in. Yes, the in, or equal to pin number what? 14, 14 OT pin of Ht12D decoder. You should not scrape. Okay? Step number 7, number 60. For Ht12E encoder, Precious, read for us. Step number 60. For Ht12E encoder. Pull up. Pull up the pull up or connect. Pull up what? The transmission enable pin. To the OT. A to the ground. Okay. So in HT, stop writing. Hello. Stop writing. In Ht12E encoder, we had a pin we call TTE or transmission enable pin. Which is pin number what? Which pin number what? 14. Number 14. If you forgot, just open the physical appearance of Ht12E encoder. You have it in your exercise book. So it's pin number what? 14. So what is a corresponding pin to the TE or transmission enable pins in case of Ht12D decoder? I say, please examine the physical appearance of Ht12E encoder and the physical appearance of Ht12D decoder. Then, in Ht12E encoder, we had a pin called the transmission enable pin. In also Ht12D decoder, we have another pin, which is corresponding to what? The transmission enable pin. So I want you to mention to me, which pin do you think that's a corresponding pin? Ima, today you don't have exercise book? Okay. Thank you. What the corresponding pin of transmission enable pins in case of Ht12D decoder? A? Pardon? 15? VT. What the long distance of VT? Valve transmission. So it means that in case of the encoder, we had the transmission enable pin, which it has been labeled like this one. Right? This one correspond with what? Correspond with VT, valve transmission pin. Right? So in case of the encoder, we connected this one. We pull it up by connecting the common ground. Go and dress yourself. Omachi, also go and dress yourself. Number 6. So he said that leave the, so VT, it is pin number what? 17, right? So leave the pin, so leave the VT or pin number 17, pin number 17 or 17 pins, leave it free. So we don't connect it to the ground. We don't connect pin number 17 to the VDD. We don't connect to maybe to the resistor, whatever. We just leave it free. Say, leave it free. Tell your neighbor, leave me free. Tell your neighbor, leave me free. Number 7. Number 7. Read for the Ht12E encoder. Step number 7 for Ht12E encoder. Connect what? The Ht12D decoder IC has what? Has a built-in oscillator that require what? That require the external resistor to produce oscillation within it. Say built-in oscillator. Class, say built-in oscillator. Again, say built-in oscillator. So Ht12, hello, stop writing. The Ht12D decoder integrated circuit, matatu, it consists of a built-in oscillator. And this built-in oscillator does not need maybe a external Christ oscillator like in case of microcontroller and microprocessor. Itself, it just needs an external resistor. Say external resistor. Say external resistor. Similarly, in the Ht12E encoder, we had the situation like that. But remember that the resistance of the resistor will be different according to the data sheets of the manufacturer of a Ht12E encoder and the Ht12D decoder. Are we together? Are we together? So you expect it to connect your T, a resistor. In which pin? Oscillator 1 and oscillator T? Oscillator 2. And these values of resistance of the resistor we're going to use in a Ht12E encoder and a Ht12D decoder, it has been declared different values of resistors in the graphs of the data sheets of these electronics integrated circuits. But we don't have enough time to just go through different values of resistance that can be used in oscillator, in the built-in oscillator of the Ht12E encoder and built-in oscillator of a Ht12D decoder. So that's why that we are going just to use only one, because of we cannot cover it within just in this workshop. We need some more time to discuss and draw those graphs, because the manufacturer drew the graph according to the different values of resistors which have been used. So the manufacturer declared the minimum value of resistance of the resistor, but used it to trigger the built-in oscillator, and the maximum. Okay? So because I told you to download the data sheet of a Ht12E encoder, you may go to the graphs. I think that this is the good time. Just go to the graph of the graphs that you find in a Ht12E encoder. Quickly. For those who have been here in last Saturday, we downloaded them. Quickly, just go to that data sheet and then check the graphs. You will find the resistance of the oscillator which has been declared there in the data sheet. Now, Joseph Benja, do you see the data sheet of Ht12E encoder? So go to the graph. You don't have it. You don't have it. And you? You? You have it. You're opening. How long does it take to open? Ht12D Decoder. Have you found it? So the graph, the title of the graph is written oscillator frequency versus supply voltage. Say oscillator frequency versus supply voltage. Say oscillator frequency versus supply voltage. The y-axis is written as oscillator frequency, and the x-axis is written as VDD. Then along the graph, you see ROS, ROSC in ohms. It means that oscillator resistance. Then the minimum, in case of Ht12, the minimum is 470 kilo ohm, right? 470 kilo ohm. But for that case, with different power supply from 2 volt up to 13 volt. Then the maximum, you may also use 2 mega ohm. The same situation for the Ht12D Decoder. Then we chose what? 680. We chose that 680 kilo ohm. Do you see it? Show me. Where is it? That 680 kilo ohm. This one. You have it. And you have that data sheet. You have been moving with it, but you didn't read it. Do you see it? Minimum is what? 470 kilo ohm. Maximum is what? 2 mega ohm. Downstairs there, on this side. Then, what the intermediate? 680 kilo ohm. So, we don't design digital electronic systems without referring the data sheet. It's just a matter of time, but I could give you the reasons of every step that you are following in connection. Have you seen it here? So now, downloading the data sheets of Ht12D Decoder. You will see also the oscillator frequency. So he said that we are still in step number 7, connecting the external resistor with resistance of 470 kilo ohm. Across oscillator pin number 1, which is pin 16, and the oscillator 2, which is pin number 17. And the oscillator 2, pin 17. So if you download the data sheet of Ht12D Decoder, you'll find that 470 kilo ohms, it's intermediate valve. Did you find it? Oscillator frequency. Oscillator frequency versus supply voltage. 27, 51 kilo ohm, 68, 100, 220 kilo ohm. Sorry, not 470 kilo ohm, 47 kilo ohm. 47 kilo ohm. According to the data sheets of Ht12D Decoder, what the minimum oscillator resistance? That because you have smiled. And I heard you smile upon Joseph Pastor. Ask the pastor to help you. He was also smiling. Okay. So, according to the data sheets of Ht12D Decoder, the minimum oscillator resistance is 27 kilo ohm, and then the maximum is 220 kilo ohm. Okay? So 47 kilo ohm is in between. Then step number 8. Step number 8, according to Ht12D encoder, read data sheets. I taught you 3 workshops about data sheet. My dear students, in case you want to understand practical electronics and practical telecommunication engineering, learn how to read data sheets of electronics components and user manual. And user manual. You should not engage yourself to use any electronics equipment or device without going through its user manual, because you might destroy it first of all. And step number 8, Eliakim Matthias, what was the step number 8 of Ht12D encoder? Connect it to what? The out. The out pin, or pin number what? 17. Right? To the what? To the data pins of 433 megahertz RF40 transmitter module. What do you think about for the decoder part? So for the decoder, it means the 8th step is actually talking about the output pins. How many output pins do you have in decoder? Joshua. Connecting, so you have 4, right? Connecting either 1 or 2 or 3 or 4. Output pins of 40 output pins of Ht12D decoder. I see. Connect either 1 or 2 or 3 or 4 output pins of Ht12D decoder. I see. To the other output peripheral. Other output peripherals. For instance, for our case, we're just going to connect it to the indicator, just equal to data indicator unit. So as we discussed that, when we the aim of designing this short distance wireless communication system is just to transmit information from one point to another point, and when that information will be received, we expect an action to be taken. So it means that once we have the outputs from the decoder, we might connect it into the control system, another control system, or we might connect it directly to the, maybe we call them drivers or electronics drivers, for instance, motor drivers, and then we connect to the actuators. So you can have your transmitter systems at this point, and have your receiver system at this point. So you can actually have an input to the transmitter, which will affect the output connected to the receiver. That's what you use to actually experience in case of air condition. So it means that in case of air condition, actually we call it the remote, it's a transmitter. In case of the air conditions machine, there is a receiver unit. And once the commands from the remote has been received by the receiver unit of Edison want to buy one of the window cars. Edison wants to buy, while I'm explaining about Yoti, a remote and air condition, Edison is actually maximizing the profit of window cars. He's zooming. Then step number 9 is what? So you may use either 1 output pin or 2 output pin or 3 output pin or 4 output pins. And sometimes, however, that we will not cover in this module, you may also have some other. I can combine, listen, remember that we can use the principle of combination. You know combination in mathematics, in probability? we can use the principle of combination to actually maximize the number of inputs and the number of outputs of 40, the number of outputs of full decoders. How? You know that we talked about combination, right? Combination is, we call it N, combination what? P. We taught you how to arrange letters. Let's say A, B, C. But anyway, let me just don't confuse you. We can remember that we said that an encoder, it has a maximum of 40 inputs, right? A decoder, it has a maximum of 40 outputs, right? But also, in case of the encoder, I can have some other inputs by combining two inputs. For instance, I can actually send the signal, the 2 bits, instead of sending 1 bit. It may be connected in AD8 and AD9. That's another sequence of bits. Oh, okay. Just ignore what I say. But one thing I want to tell you, the goodness of electronics and special communications engineering, or the goodness of electronics engineering, we are not limited with the 4 inputs of encoder. Also, we are not limited with the 4 outputs of decoder. We can have more than 4 inputs of encoder, and we can have more than 4 outputs of decoder within this Ht12D decoder and Ht12E encoder. How do we generate some other inputs? That is good. We combine 2 inputs. Then remember that if we combine 2 inputs, it means that the encoder encodes the 2 inputs at the same time from 2 different pins. Right? And the decoder will decode the informations and just to provide another command from the 4 first command. For instance, we can combine AD8, receive the inputs from AD. Listen, the encoder can receive the input from AD8 itself and encode it. Also, the encoder can receive the input from AD8 and AD9 at the same time and encode it. Are we together? Also, the encoder can receive the input from AD8 and AD8 itself, as we discussed that, and encode it, and also from AD10. So it can receive the input from AD8 and AD10 simultaneously and encode it. So this is another set. So this is input number 5. This is input number 6. Also, the encoder can receive the input from AD8 and the AD11. This will make another input number. This is 5. This is 6. This is what? 7. Also, the encoder can receive the input from AD8. Yes, AD8, AD8, AD9, AD8, AD10, AD. Okay. So you can receive also the input from AD9 and the AD10 at the same time. This is input number 8. That's the goodness of digital electronics. I know that some of the students did not understand what I said and what I presented. Just ignore it. But just I told you that you should not be limited with the 4 inputs, data pins of the encoder, and 4 output pins of 40 of the decoder. We can have a number of the possible combination of the inputs. You used to see robots, and then you think that just within a robot that we have maybe ICs which can accommodate all the functions of the robot. Who told you that? No. It's just a matter of logical operator. Because, for instance, for this case, if you want to write a program, you are going to use the AND operator, the OR operator, the NOT operator, and exclusive OR operator in case of the embedded computer programming language. Oh, good. You are welcome to the Electronics and Telecommunication Engineering. For instance, myself, I designed the automatic weeding robot by using this Ht12E encoder and Ht12D decoder. So my robot required 6 inputs and it can perform 60 functionalities. Okay, good. We are not entertaining you, we are teaching you what we have been practicing. Number 9. Number 9, we said what? Cross check what? A. Cross check all the what? A. All the connection. Before what? All the connection within your circuit before turning on the power supply. And it's very important in case of electronics. Then once you know those steps, you can draw now the overall schematic circuit diagram. Is it? Can you draw the overall schematic circuit diagram? Because the next schematic circuit diagram is just for the receiver unit. Once you finish that, you draw the overall schematic circuit diagrams of the transmitter unit and receiver, and you enjoy electronics and telecommunication engineering. Kim, welcome for the question. All the address pins are no. Or once you buy the Ht12D decoder IC, none of the pins is connected to elsewhere. You are the one who have to decide. That is something else that you have read. I know what you have read. Just forget. Now it is what? Joseph Benjamin, it's what? Joseph Benjamin, it is a time for what? Joseph Benjamin. Overall, schematic, logical, circuit, diagram of what? Of short distance wireless receiver by using Ht12D decoder. So you know that you have to include the power supply. Okay, but because that we have different way of understanding, let us go it quickly. So this is our testing point A. This is switch K. Remember that we have been talking about this concept in terms of number. There are also some mathematical formula which I'm not mentioning, but they are there, and mathematical equation guiding about this system. But also we've been talking about these concepts in terms of some simple tables in case of the features, and they've been discussing about these concepts in terms of the diagrams. But remember that all of those binary codes, I'm talking to you students, including Happiness Lugano, all of these concepts, also the binary information, the carrier signal, are always existing in terms of waveform. We did not talk about the ear graphs or the graph of the information which is processed, but you have to go through yourself. Are we together? Should know the graph of the input, should know the graph of the output. Why are we not talking? We have discussed about it in previous classes. But also I'm trying to summarize the concept. So you know that here we need just a resistor. And then you have the LED. For this case, you're going to use a resistor of 300 ohm. So this is, we are drawing according to the hardware implementation. Pin number 1, pin number 2, pin number 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10, 11. Who is talking? Shukuru, eh? Huh? So this is Ht12 Decoder. Okay, so we say that if you are building this circuit, because you'll build it on the breadboard, if you are building this circuit, you'll be using one jumper to connect to pin number 1 and pin number 2, A0 to A1. Then you'll be using one jumper to connect it A1 to A2, and be using one jumper to connect A3 to A4, and using one jumper to connect A3 to A4. Then this one should be connected to the we have to connect it to here. Then this is pin number 18. We say that should be also connected to the power supply. Then we say that we have to take a jumper in case that, but if it is, we are using Vero board or PCB board, we are not going to use jumper, we are going to use copper material. Hello, hello, hello. I'm drawing while I'm teaching. Students, I'm drawing while I'm teaching how to do it. If you are using Vero board, we are going to use a soldering wire actually to connect pin number 6 and pin number 7. If you are using PCB board, Brighton cannot stop. If Brighton stop, I have to stop also. So if it is PCB board, we are going to use copper. If it is Vero boards, we are going to use soldering wire to connect the pin number 7 and pin number 8. If it is PCB boards, we are going to use copper. They may. If it is PCB boards, we are going to use copper to connect the pin number 8 and pin number 9. But this is, we call it common ground. Hello, Joan. Listen. Then we say that this is AD8, AD9, AD10, AD11. But remember that according to the previous overall schematic circuit diagram of our transmitter unit by using Ht12E encoder, we connected our input in AD8 and AD11. Similarly, we can take out the output. Oh, Bundala. Bundala. Now it's drawing. What did I say, Bundala, before I called you Bundala? You were not there. So this will be talking about output later on. We have to follow the steps. Step number 40. So how many steps are we done right now? I think that 3 steps, right? Step number 4. Step number 4. Class, step number 4. This is step number 1. Step number 2. Step number 3. Step number 4. Step number 5. Step number 5, read step number 5. Those are the steps that we are following to draw. We don't draw it from our mind or the way that you want. Step number 5, students. A. So data pin, it means input data pins. Pin number 40. Pin number what? A? 14. So 9, 10, 11, 9, 10, 11, 12, 13, 14. So this one, we have to connect it. Look, please, I said stop writing. We have to connect to the data pin. So the data pins, the RF, the 433 RF receiver, first of all, it has an antenna, its own structure. It has an antenna, receiving antenna, but also it has two data pins. Hello? I said stop blowing. Listen and watch. Because I don't have, I will leave this receiver as your homework. So itself, it has 4 pins. One pin is for the power pins. So you can take power from this point. Yes, you can take power from this point and connect it to the power pins. This we call the VCC pin. This is 433 megahertz RF receiver. This is the one that will be receiving the binary coded from the distant T, short distance T transmitter. So it has 2 data pins. This is the first data pins, this is the second. So this is data pin number 1, data pin number 2. But another pin, it's a ground pin. So it has a ground pin. So you can take a photo. Do you remember that in previous session I gave you to take a photo of it? So it has 4 pins. One pin is for power, another pin for ground. The 2 pins, especially that the middle pins, are for the data. Hello, Raphael? Fatuma Makame? Okay, and step number 5? Pardon? A? Connect external resistance, step number 6. Step number 6. Read the steps you have in the exercise book. Leave the VT or valve transmission pin free, right? Valve transmission pin is pin number what? A. So we will not connect these pins to anywhere. Hello, hello, hello. Hello, hello. Very good. On my behalf. That is Bongo lane. That is Bongo lane. No, I don't want. The next step, step number 8. Connect what? A. X resistance of 40, of resistance of 40. A for 4. 47. So this is resistor with 47 kilo ohm. The next is step number 8. Connect the either 1 or 2 or 3 or what? 4 output, right? According to our design. How many inputs did we have in transmitter? Kankesha, how many inputs did you have in transmitter? Kankesha, how many inputs did you have in transmitter? Mwatatu, how many inputs did you have in transmitter? Boniface, how many inputs do you have in transmitter? Boniface. How many inputs did you have in transmitter? Dixon Diegula? 1. Jacqueline Balele? 1. Pili Nasibu? 1. So now the language is 1, 1, 1. Happiness Lugano? Are you in class today or you're just outside the class mentally? Shane? How many inputs do you have in transmitter? 1. Oro? 4 inputs. Mexina? 1. Urasa? Now Urasa, we congratulated Urasa in this class. Class, do you see Urasa? We congratulated Urasa, and now Urasa is Urasari. That's the danger of congratulating students before the end of 40 of the class. Matcha. How many inputs did he have in transmitter unit? 1. Glory. How many? 1. Eliakim Matthias. How many inputs did you have in our transmitter? A. Unknown. Yuda. Simon. 1. Mugisha. 1. My friend there. Hello. 1. God bless. Skuru. Give us a different response. I'm just finding a different response. Angelina, give us. How many inputs do you have in your transmitter? 1. Oh, my God. Adamu, Abdallah, how many inputs did you have in a transmitter? 1. 1 or 2 or 3 or 4? Sure. Winfrida? 1 or 2? Lucy? 1. Namvua? 1. Without even bothering. Sita? 4. Zuena? 1. Hawa? 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 My dear student, we are now on the receiver side, but unfortunately, most of you have forgotten what you had in transmitter. In transmitter, we use the only 2 pull-up resistor network at AD8 and AD11. And I told you that, remember, because we are going to record these inputs in the receiver side. Look the overall schematic circuit diagrams of your transmitter unit. Look, of Ht12D encoder to get the response of that question. Look it. Go back to workshop 7. Go back to workshop 6, I think. Yeah, 6. How many pull-up resistor network did you have? This guy did not even put the value of pull-up resistor, did not even label. Yes, do you see how students are intelligent? So there's no the value. He's the expert on writing just the symbol 40 of resistor. So how many inputs did he have in a transmitter unit? 2. You have the response in the exercise book. But it is still in the exercise book. It's not in your OT. So if it is 2, according to our design, we are going to connect it 2 output pins. That's all. Because remember, receiver does not receive anything which is not being sent by the transmitter. Okay? Well, so he's saying we are going to use just the, we call it just the receiver indicator. So we had this is called AD, this is called 88. And also another ones, we are going to deliver it or to take from AD what? 11. So for this case, you say that these pins, we are going to use just an LED for the matter of demonstration, but you may use any other electronics component. So this is LED. So let's say that you can have color, 2 different color, ready, and this is green. Green LED, and here, so this one is 200 ohm resistance of, this is R3. Then here we are going to have another resistor of 240 ohm. This is R4, and here we have a light emitting diode, and this one we have to connect to ground. This is what let's say yellow LED. So this is figure, for today this is figure what class? Figure 5. Then, what are the names of the figure? The overall schematic logic circuit diagrams of what? Short distance wireless. So for the encoder, for the decoder, it means that all of this one result to what? 433 megahertz receiver module. But once we have 433 megahertz or 315 megahertz receiver module, then we don't call it a decoder unit, we call it a receiver unit. Class, are we together? Class, are we together? Okay. Ask me a question about what we have discussed there. We discussed about numbers. We discussed about diagrams. We discussed about tables. Because I left the assignment for you to go and draw what the schematic circuit. Yes, you should include also the testing points. I have told you how to choose the testing points. But just to redeem the time, just let me leave it for you to choose the testing point, the best testing point for this circuit to analyze whether it's working or it's not working. What we did not discuss, the waveform. Why? Because what we discussed about digital data, you know the nature of the waveform. We discussed about the analogy or sinusoidal carrier signal, you know its nature. We discussed about amplitude shifting key. You have to know how the modulated signal looks like in the OT, in the waveform. Adam, you have a question? You're welcome. Yes. I made a mistake? Positive terminal, negative terminal. Thank you very much. Positive terminal. So I made a mistake here. I made a mistake. So this is a receiver unit itself. An assignment I'm leaving to you, draw the overall schematic circuit diagrams of 40 short distance wireless transmitter unit and the wireless receiver unit. So this one plus the one we drew in workshop number 6. And you'll enjoy electronics communication laboratory. That's one of the assignments or one of the homework. Then another homework, go and read about 433 megahertz receiver module. Then if that's the case, and you say there's no any other question, I'll let's say this is the end of workshop 8. And this is all about what, or this is just a part of what I've prepared for you in case of encoder or in case of decoder concept. You have a question? Okay, you're welcome. Draw it. I know most of the students, including Jessica Zakaria, okay, is taking photo and say, I will draw it if God wishes. So that is one of the drawing. There's another one you have developed from your mind, which is the combinations of transmitter and what? Receiver. So that one will draw it at your home place. But that one's draw it now. You don't have time. You may take a photo of it and then remember that photo after exam. Okay. Oro. Okay, thank you. So Oro is asking a question that I heard also some ladies who have been asking in front here. When they've been discussing about valve transmission pin, they asked me a question, why should we leave it free? So there is the answer, but I don't have enough time to tell you or to teach you why do we leave it free. It's another story. So just understand for the moment, we just leave it free. But why? And what if we don't leave it free? What happens? Just leave it for the next discussion. Okay, Oro? Oro? Is it okay? Yeah. So, another question. Okay, Ruben. Draw it. While those students are asking questions, I know that you don't like the questions they are asking because I know that you are thinking to go out. So while you don't enjoy those questions, for you just draw it. You don't draw it. You just draw the LED like a lamp. Yes. Just go to the question. I've understood you want to ask it. You have two transmitters and one receiver. Or maybe you have two receivers and one transmitter. Okay, thank you, thank you. Ruben is asking a question that he has understood about the wireless transmitter unit and wireless receiver unit. If it is a single unity and another single unity, he doesn't have any problem with it. What if we have two short distance wireless transmitter and one short distance wireless receiver? How will that receiver distinguish the binary coded from transmitter 1 and transmitter 2? Right? And then another Ruben's question is, what if we have a single transmitter, but we have two receivers or three receivers, let's say two receivers, made by the same encoder and same decoder? Then how about that receiver? Will it, okay, we receive the single information, but will both of the receivers receive the signal sent by the transmitter 1? Or one of them will receive while the other one is not receiving? So I want to say that that's a very good question. And especially in order to teach students, because sometimes in electronics, in order to solve a particular problem, we can have a number of sensors. We can have 4 sensors, and sometimes, for instance, the one we had that one, which is called automatic weather information system for the East Africa, we used more than 7 sensors. So for that case, we have to build something called the sensor network, right? So sometimes also we can have that station here. We have that station at DIT. We have another station at JNIA. We have another station at Sengerema. We have another station at Mwanza. We have another station at Bunda. We have another station at Musoma. And all of those stations, they will send the information to the repository or to the DIT servers. And how will the server distinguish those information from different transmitters? So what I want to tell you, your questions is good, but we cannot cover it in this module about the sensor network. Just keep it. When you build it, for instance, we are going to do the practical, and then we'll have 2 different transmitters. You can practice. However, you don't understand what is happening, but you can practice to see what will happen. Okay? So thank you very much. I will say that this is the end of workshop 8. I think that, did you understand? Have you understood? Okay, so now it's a time to congratulate you. It's a time to congratulate you for the hard work. You have been slumbering, you have been sleeping, you have been waking up, you have been disappointed. 1, 2, 3. Hongera. Imara. Wow, I thank God who have given me this opportunity to teach you. May God bless you. See you in the next workshop.